Hello, good morning, good evening, data science learners. Um, Today we'll be seeing some Spark fundamentals. If you have seen my previous lecture on Spark architecture, how actually the Spark utilizes the clustered environments to distribute the tasks and then get them executed. So you would have a basic or minimal understanding how the execution in the background would be happening. If you did not see that particular video, we'll post the link in the description of this particular video. You just watch that video where you will understand the Spark architecture, the advantages of Spark, and the different components that are actually involved inside the Spark framework. Uh, so today what we'll see is we'll see uh, the different basic functionalities of Spark, like we'll see about Spark Web UI, what we can do in Spark Web UI, and then we'll be seeing about running the Spark inside Jupyter Notebooks, and then we'll be seeing how to create a Spark RDD, which is a resilient distributed dataset. That is the core fundamental concept of Spark. And then we'll see how to create a Spark data frame, and then we'll operate on that particular Spark data frame with few functions, and then we'll play around them. But more in detail, we'll see them in the next video. And then we'll see what are all the different file formats that is Spark support, such that to read the data into the Spark data frame. And finally we also see some Spark SQL, how you can write Spark SQL, because that's the same thing that we are even discussing in the lecture 1 as well, how we can leverage the capabilities of SQL while dealing with Spark. So this is all the content that we are going to discuss today. So what I have is here, let me close and then reopen and then show you guys what exactly this is. So okay, so I have my terminal open, so let me clear it, minimize. I don't need any terminal. So I have something called a data spell, which is actually a licensed edition from IntelliJ, but you have a Jupyter Notebook that you can directly take the advantage of Jupyter Notebook, which is open, and then we can use of it. But I am little flexible and then habituated to use data spell, so I'll be using this. This is almost equal to your Jupyter datasets only, even I'm sorry, Jupyter Notebook only, and even the same kind of shortcuts and everything would work in data spell. Okay, so now let me try to just a second. Okay, so let me try to attach new and then attach directory. So basically I'll try to create this on desktop. So I'll say PySpark fundamentals. Okay, and then this got created. Okay, so let me keep it down, and then from where from here in the context menu I can create a Jupyter Notebook. Here I will say Spark Playground. Okay, I just named it as playground because we are going to do a lot of things and then we'll play around them. Okay, and moreover okay, so before we move on, let me show that which version of Spark is been installed here. So I say PySpark hyphen version. So my version of PySpark should be greater than or equal to 3. Yeah, it's 332. Okay, so the reason why I shown you the version of PySpark that is installed in my machine is there is a small difference that's basically catered from version 1 to version 2, which is called a Spark context and a Spark session. So previously in version 1, we used to deal with the Spark context. Basically, Spark context is the entry point into your program, from where the execution exactly starts with, and using that context we used to create resilient distributed data sets, which is RDDs. Okay, and then play around those RDDs, like you can do filtration, you can do some aggregation functions on it. So all those things we can do. But after Spark 1, which is like Spark 2.x onwards, the creation of datasets has been shifted into something called Spark session. So Spark session ideally is a gateway to start the program, and then using the Spark session you can create data frames and all. Ideally these data frames and RDDs, internally it is all RDD again, but it is more easy way of creating creating a data frame, so creating an RDD in fact. Okay, so let me with that first of all I'll show you how to create Spark context, and then slowly we will shift on to Spark session. Okay, when I say that the Spark context is in the earlier versions of Spark, it doesn't mean that it is like it's completely killed, but it's like a deprecated version. You can still use it, but more functionality has been enhanced into Spark session. So better use of Spark session instead of Spark RDD. Spark context, because the parallelism and all you have to manually code inside Spark Spark context, but whereas the Spark session by default runs in parallelism. Okay, so let me do here from PySpark dot SQL import Spark session. And from here let me get this Spark session. So if you see it, like already automatically my Jupyter server has got started up here, and now we can say Spark. So this is the global variable to hold the Spark context, and then from that particular context we'll create an okay simple RDD we'll create first, and then we'll see how it looks like. Very simple one. Okay, so for that what we have to do is Spark session dot builder, because Spark session uses the builder frame builder pattern to create that Spark object. Okay, dot builder dot app name. So what exactly, basically we are giving a name associated to this particular session. Okay, I'll say PySpark dev, and then dot master. Master is basically where you can actually use your Spark server. So if it is a remote server, you'll specify the remote server URL, Spark server URL here. Since it is local, I'll say local, and then you should basically pass the number of threads that parallelly get executed inside this Spark server locally, or Spark node, worker node basically. These terminologies you will understand if you go and see my the previous video of architecture, what is worker node, where the task is being executed. So if you want parallelism, so you should mention the number of threads in how many parallel threads that it wants to execute. And now I'll give star, which means that all the cores of my machine will be used for parallelism. If I say 2, that means like only 2 threads out of the whole course that I have. So only 2 threads will be created, and any task that is given, it will be executed parallelly on these 2 threads. Okay, so to increase the speed and the processing power, so I'll make use of my whole course or the total course that I have. So I'll say local star, and then dot get or create. So that means like if you have already existing session, so it will get it, or otherwise it will create a new one. Okay, okay, so it's created now, and then just a second, I'll show you something now. So if you see, by default when Spark starts, so it opens something on Spark Web UI. That is what I was saying. So we will even deal with Spark Web UI. In Web UI you have four major things, like the jobs, like what are the different jobs that are being executed, stages. So for each job there will be different stages in which the job executes, and you can actually trace through that particular stage what exactly is being happening. And then executors, basically how many what are the different executors, how many RDD blocks are being created, what is the failed task, active tasks, the number of cores being actively executed. So all these things would be captured here. And then environment, so all the environmental setups or settings you would be getting it here. And then going to jobs, let it be here. I'll get back to this once needed, and then I'll show you once the time comes actually. Okay. And now what we'll do is we'll do a small program. So we'll say spark dot spark context. Okay. And then we'll say dot parallelize. Then we will create simple data set like 1 2 3 4 5 6 7. Okay. And then we'll say this is as RTD, and we'll collect this as an RTD. Okay. And now if you run it, so it executed parallelly and created an RTD. Now I'll say RTD dot I can do anything. I can filter all the even numbers, I can filter all the odd numbers, or I can sum up, or I can count how many numbers are there. So I can even do a mean, and I can even convert to a data frame. So a lot of things are there. I can even map and then give a function to it, and then I can do that. So simple thing that we'll do is now filter, and then filter takes a function. So I'll say lambda x such that I'm sorry, I'm writing a different syntax, x such that now what we'll do is x percentile 2 equals to 0. So this basically gives you all the even numbers. Okay, so now if you execute, yeah, it got it. So dot show, not dot count. Okay, so this will give you the count of all the numbers. So we have 2 4 6 8, so 4, so we have 4. Now let's go into the web UI, and then let me bring back the web UI. Okay, so here is the web UI, and now I'll refresh it, and you see this. So if you click on it, and then this is how it got executed. So the minimum is 0.7 seconds, and it maintained it basically. So it created an RDD, and then finally it did it. And so what it did is like executed driver ID, and then where it actually executed, how many parallel threads has been run, all these things. So almost like 10 tasks has been run for that, and then to do that particular functionality of filtering the even numbers out of the given array or the RDD. Okay, so basically we call this visualization as a DAG, which is called directed acyclic graph. So Spark internally maintains which task has to be completed first and which has to be succeeded next. So that will be followed as a DAG, and then this DAG gives different informations like how many RDDs has been created, which RDD is getting processed, different kinds of a map reduce operations that internally it does on top of the RDDs in memory. So all these things would be maintained as a DAG, and then using this DAG you can actually trace back what exactly is happening underlying the system. Okay, so let me get back this. This is how you create the Spark RTD, and then do a small operation on an RTD. But there is a different way of creating a data set as well, right? As I said, so Spark session, directly using a Spark session itself, like you can create a data set, yeah, data frame, I'm sorry, not a data set, a data frame. Okay, so for which let me basically create one small data which is like an array of tuples. Okay, so I will say this as Pavan, and my last name, maybe like we'll say first name, middle name, last name. Okay, and then we'll say date of birth, which is like zero, sorry, 10 04 26, and then what shall we do? I'll say gender. Okay, and then maybe like the salary. Okay, so maybe this is good to start. So I don't have, maybe I'll say my middle name is Kumar, and then my last name is Mamta, and then we'll create a set of these kind of users. Okay, I'll say this as Arun Kumar Pudi, and then male, I'll say this as 87, but this is second, and then 15, and then this is Ramu, I don't know middle name, I'll say Seti, and then Ravi, middle name is Kumar, and then say Nani, and I'll say this as 55, this as 25, this as 35, this as 22, 63, and then 77. So this is Rama Rao, I don't know the middle name, and then I say this is Modi, one more, maybe like for I'll say Divya, I don't know the middle name. Okay, and then there is a don't know most of the middle names, and then last name is okay. So we just need to change few genders, female here, and then female. And if you have existing dataset, you can directly copy, instead of I'm making it myself now, and then we just need to change this all, maybe like I'll just a second, I'll try in some web and then I'll get it instead of me making, because a lot of things I need to change. So let me okay. Okay, yeah, okay, fine. So I got almost the same dataset. Yeah, they gave the same kind of dataset. Okay, now what I'll do is this data I need, and then I just mentioned the schema. Schema is basically which define the structure behind the data. So columns is equals to I will say this as first name, then say name, and then this last name, and then this birth date, and then gender, and finally say salary. Okay, now how to create a data frame using a Spark session instead of using a Spark context. So you say Spark dot create data frame, that is direct function, so to which like you need to pass data is equals to your data, and then to give the structure, so you can say schema is equals to your columns, then this will give you the data frame. Okay, so you just execute it, so it executes and creates a data frame. Now if you want to see the schema of that particular data frame, So you have a function called print schema, so which will tell you like what is the schema of that particular data frame, and then if you want to inspect that particular data frame, you can say show. So that is how you can see the data frame. Okay, so this is how you can create a data frame. Now what are the different externals? This is creating a data frame manually, so that means like you have a data, you copied it, and then you are creating the data frame by explicitly passing them into the data structures and then attaching the schema to it. But what if suppose you have a file which is already residing at your some location, and then you want to use it or create a data frame out of that, and there are n such different file formats that a Spark supports, out of which like most well known are like CSV, text, AVRO, bracket, TSV, XML. Okay, I didn't get much chance to work with AVRO and bracket. Most of the times I go with CSV and JSON files, and even in this demo also we'll try to see an example with CSV file. Okay, let me borrow my CSV. I used to have some CSV file. Let me get that one. Yeah, I got it. So yeah, I'm putting it here. So, okay, so I have some user data. Don't worry what exactly that user data is and all, we'll see it. Okay, so I don't want to open the file itself right now, so we'll see it. So using the Spark, so let me execute everything now. Okay, let me see. Got stuck. Type. Okay, let me close and reopen this file. Maybe I'll stop my Jupyter server. Okay, run it, rerun my file. Let me close and reopen the IDE. Sometimes these kind of problems happen. Okay, data spell. See, now the cursor is coming actually. Okay, so what we'll do is let me re-execute. Yeah, Spark session created, context executed, filter executed, and then data frame got created, and then we are seeing it. So let's read the data from this user data file and then display it how it looks like. Okay, so using Spark there is something called a read, and then there are different formats, so you can directly read the CSV, or else you can say dot format and then pass the format of that particular file. So you see the first argument is path, and I'll say the user data. Now it creates user underscore data, user data. Okay, user underscore df file, so user data frame. Okay, so now you execute and then see. Okay, now you can even do the same thing, use data frame dot print schema, such that you will see the schema. So if you see this, it inferred the schema as the columns C0 to C12. That means that there are 13 different columns, and then if you inspect the data how it looks like, so you say use df dot show, and if you run it, okay, so you look at the first row which says like registration, DTTM, ID, first name, last name. So that means your header is actually considered as one of the data item while reading or processing this particular file. So there is an option while reading which says like yeah, there is a header for this particular data set or the file that is being read by the Spark. So you can say header equals to true. That means like it identifies, okay, there is a first line of this particular file which is being read as a header, and then it will inform the schema based on that. Now if you see the schema, it has been changed with respect to actual column names, and now if you run it, so you have the column names here. Okay, so now you can play on this particular data frame like as you wish. All the built-in functions, user defined function, UDFs we call, and then different operations on this. We'll see it in the next session more in deep, but I'll show 2 to 3 different activities here. Okay, so you can say user data frame dot filter. I can say out of one column, right? So I can say user df of maybe like gender is equals to female. I think it is female, right? Yeah, female dot show. So that means only I should get females. So if you see all the records in this particular thing, you see only females. Okay, so that means like I filtered them out. There is a different way of filtering out. If you want to say that I don't want to use the data frame every time, so and you specifically want to use columns, then there is something called from PySpark.sql.functions. I'll import every function. Okay, so now you come here and you can replace this as call. So call is one of the functions which refers to column. So column gender equals to female, and then your output doesn't change, but the semantic how you wrote it, that changes basically. Okay, so this is how you can play with the data frame. You can actually say salary greater than so and so, all these things, different things that you can write. Now I'll also introduce a small thing to SQL as well. That is what I said. So how to create that particular SQL. So now you say use a data frame dot create or replace a temporary view. So out of this data frame you can create a view which is nothing but a table kind of a structure. So I'll name it as user underscore master. So this is a master data for user. So I'll say user master, and then I'll execute this. So that means like a view has been created. Now inside this Spark global object, so I have something called SQL, and I can write direct SQL. Select first name comma last name from user underscore master where salary, I have a salary here, salary greater than maybe like 40,000. Okay, then execute. What happened? So user master project. Okay, maybe first name is not there, maybe the column name would be different. First underscore name. Okay, so it says first underscore name and last underscore name, then execute. Yeah, it got executed and it has the data. Now I'll say show. Okay, so these are all the data for those who has the salary which is greater than 40,000. Okay, so this is how you can write SQL queries, and then you can play with them, and then this is how you can read the file and then create a data frame out of it, and then this is how you can manually create a data frame using the data, explicit data, and and then this is how you can create an RDD and then play different functions on RDD. This is just a playground session of what a Spark can do, and now as a final attempt I'll just wanted to show how many things we ran now. So inside the jobs, if you go, see these are the different things that ran, and everything is succeeded, nothing got failed. So succeeded by total, so one out of one, we have one succeeded. And if you go here, so it has generated a code gen, and then it has a mapping partitions and internals. That's what I was telling. So it will do a map, reduce, join, all those things it will do, and then every section you can go and then identify in that particular section what actually is being happened. Okay. With this we'll conclude this particular Spark fundamentals session, or a Spark playground session. In the next coming sessions, we'll be discussing more deeply on the inbuilt functions and Spark data frame manipulations more rigorously. Thanks for watching. Please share, subscribe and like to the channel, and if you did not see the previous video, as I said, please go ahead and watch. We'll provide the link in the description. Thank you very much.